WebSockets is a fundamental shift from HTTP request response, which is more like, you knock on a door and then you wait for somebody and then they open up, etc. It's a very slow and lengthy pattern to something that's real time, like a water pipe where the water is going back and forth and it's a multi-directional communication or real-time communication. And when you do this with Rust, it allows for very efficient and amplified zero cost abstractions and compile time guarantees. So you're going to get all the safety and really the efficiency of Rust, but also you can do things that are very low latency as well. So if we look at SQLite, it could be a good place to start with doing a WebSocket demo, and the Rust ownership model is a great place to play around with that. And so that's probably where I would recommend people start with. And you can, of course, see these kinds of demos and full starter code on Pragmatic AI Labs. And let's go ahead and talk about some of the things that I think are cool about WebSockets with Rust. So first up, we have zero cost abstractions, also memory safety with Rust and WebSockets, so you don't have to worry about some of the common vulnerabilities. And also the async await ecosystem is ideal for handling these kinds of connections. So really Rust is designed for working with these kinds of systems with WebSockets, and the strong type system makes it very simple to get correct message handling. And then in terms of the ownership model, it's perfect for managing connection lifecycles. And you also can do cross-platform compilation to different deployment targets. So for example, you want to build a very low latency ARM-based target, that could be a great place to do it. If we look at project implementation as well, you could leverage Tokio for async runtime efficiency. You could have structured error handling with custom result types. And you also could get a very clean separation as well and have thread safe SQLite connections. So there's some really interesting things you could do with SQLite, WebSockets, and Rust. And of course, as I mentioned, I have these code examples on Pragmatic AI Labs, as well as full walkthroughs of how to build these. And this is a good starter kit, I guess, to build, especially in the embedded space or in targets like ARM or Raspberry Pi. There's some really interesting things that this opens up. So let's first talk about the core concepts of what happens with WebSockets. It's a full duplex communication protocol over TCP. TCP, the protocol, is really a handshake protocol. So you give a little bit of data, you get a little bit more data. It's kind of a back and forth. And so it's able to deal very well with the TCP connection in Rust. We also have the ability to do a persistent connection between client and server. So this allows different kinds of communication. I mean, for example, like a game-based workflow or a real-time handshake where you want to do some kind of specialized machine learning system. And also the bidirectional data flow is really awesome, where you don't have to, reconnect and reestablish that socket connection. It just opens and then you can just start going back and forth. And it's a enhancement of HTTP. So it's a upgrade mechanism for HTTP, and it's frame-based message transfer and also very minimal protocol overhead. Now, in terms of the technical implementation, you start as a regular HTTP request with an upgrade header, and then you have a WebSocket URL scheme. You do this initial handshake. The server responds with sec WebSocket accept. The connection then remains open after you've upgraded, and you can do binary or text messages and have control frames for connection management. So some of the ideas here are that you have advantages over HTTP. So you have reduced latency for real-time updates, a lower header overhead, no connection establishment, server push capabilities without polling, native browser support via WebSocket API, and also suitability for event-driven architecture. So the common use cases here are real-time collaboration, live data streaming, financial market data updates, multiplayer game state sync, chat applications, IoT device communication, live monitoring as well could be another one. And then Rust, this is where it really comes into play, because you have the ability to do advanced concurrency models like the actor model. You can have really good connection state management via Arc with mutexes that protect so that you don't have concurrency races. And also you have graceful shutdown with Tokio Select. some of the things to think about when you're building with WebSockets and also with Rust is, connection management, heartbeat. Like, do you want to, have some kind of a heartbeat to know when to close down the connection? That's one thing that is important to be aware of, right? You don't want to have that connection constantly open. Also, how do you scale WebSocket servers? In terms of WebSocket frame structure as well, some of the things to consider would be, payload length fields, masking for client messages, also extensions and protocols. Now, in terms of Rust performance itself, why would Rust be the ideal language? Is zero cost features, no garbage collection during message handling. So garbage collection is not a good friend of WebSockets, and with Rust you don't have that. Also, Zig could be a good example. Compile time guarantees also eliminate runtime checks. And then you have the predictable memory usage with no hidden allocations. And then in terms of the general performance characteristics, you have lower latency than regular HTTP polling, reduced server load, and then also you have a way of structuring your project as well. So in some of the examples I've done on Pragmatic AI Labs that you can download, if you have a subscription, is separate connection handling. So you have a WebSocket.rs, a database abstraction layer, DB.rs. You have a error type hierarchy, errors.rs, model definition, models.rs, and then clean or a main.rs orchestration. These are some of the things that are really important. And really, in a nutshell, we have browser API integration. So native WebSocket, on open, on close, on message, send message, transmission, ready state property, close event handling, and then binary data support with array buffer and blob. So in a nutshell, WebSocket is something that I think could be used a lot more, especially for doing, specialized kinds of tools and specialized kinds of systems, especially like really memory efficient things. Like, for example, could you build something that could detect, endangered species and have a really small computer vision model that was able to identify, let's say, 100 different kinds of endangered species, and in real time, make those connections and send that data somewhere. That could be like a really super tight and efficient thing that you could build with WebSockets, a small little model, and then maybe like a Raspberry Pi. So I think those kinds of really efficient offline kinds of systems that use WebSockets are kind of a cool way to think about things. And also maybe space, right? You could build these really efficient systems in space. So in a nutshell, WebSockets are a fun technology. You can learn a lot more about them on Pragmatic AI Labs, and I hope to hear from you soon.